Hello, my name is Carly McAvoy, and I'm looking at the prep for Math 141. This is the second video of 4, getting you ready for Math 141, which is our pre-calculus class. In this problem, in order to solve it, I'm going to start by multiplying this, and then I'm going to bring that 12 over. When I multiply this, I use the FOIL property, FOIL, and then I combine the like terms after I multiply. That should be something that you're familiar with. So I'm going to get x squared. I'm going to get 3x and another x, which is 4x, and 1 times 3 is 3. And I'm going to subtract 12 from both sides so that I move everything over to the left. So I end up with x squared plus 4x minus 9 equals 0. And this now I could simplify by completing the square. I could solve by completing the square, or I could use the quadratic formula. And that's really a personal choice, whatever you prefer to use. I'm going to start off using the quadratic formula because I see students doing that quite frequently. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, where does a and b come from? Well, a is the coefficient of our first term, so in our problem a is 1. B is the coefficient of the second term, so for our problem b is 4. And c is the coefficient of the third term, or that constant term there, which is negative 9. Okay, so we have 1, 4, and negative 9 that we're going to plug into our formula. So x equals negative b, that's the opposite of that, so negative 4 plus or minus the square root of b squared, 4 squared is 16, minus 4 times a times c. And here's where people make a mistake, just being careless about signs, so really be careful as you plug that in. All over 2 times a, which is 1. I have negative 4 plus or minus the square root of, do you see that negative 4 times negative 9 would be positive 36? All over 2. Negative 4 plus or minus 16 plus 36 is 52. And then you want to simplify 52. There's more than one way to do it. You can think about, is there any perfect squares that go into 52, which 4 goes in here 13 times. So if I think about the square root of 4 times 13, the square root of 4 is 2, and I have 2 square root of 13. Now you can do that on a calculator, but many pre-calculus teachers in the beginning will not let you use a calculator because they're trying to see if you can do some of these simple things without a calculator. So that's something to be aware of. So what I did was simplify the square root of 52 to 2 square root of 13. And now I want to do one more thing, and that is reduce these 3 because I can put 2 into all of those. 2 goes into itself once, goes into itself once, it goes into 4 twice. And so I get x equals negative 2 plus or minus the square root of 13. All right? There's another way to do this problem, and that is using the complete the square method. Complete the square, what I want to do is send that 9 to the other side. So I have x squared plus 4x. I'm going to add 9 to both sides. And then what I'm trying to do is find a term that I could then factor my trinomial into a binomial square. And so how I get that is I take b, I divide by 2, and then I square it. So for this term, 4 divided by 2 is 2, squared is 4. Now if you go to factor that, notice I have to add the same amount to both sides to keep it in check. When I go to factor that, I get x plus 2 to the second power because I get x plus 2 2 times. And over here I have 13. Starting to see where this is what's going to happen here. If I take the square root of both sides, I get x plus 2 equals plus or minus the square root of 13. I have to do plus or minus because it's to the second power. I need 2 solutions, and that's how I generate those. If I subtract 2 from both sides, I get that same answer that I had before. One way was using the quadratic formula, and the other one was using complete the square method. Now, number 6 is actually an easier problem because it's kind of all the way to here, where we were up here. We can just take the square root of both sides. If I take the square root of a square, those two things cancel out, because what a square root is if I take x minus 8 into the second power and I then take the square root, a square root is like something to the 1/2 power. So what I've actually done is taking this to the 1/2 power. And what do you do when you have a power raised to a power? Well, you multiply those. And if I multiply 2 times 1/2, I get 1, which just brings me back to x minus 8. That's why I'm doing that. I want 2 different answers, though, because I have this to the second power. So that's why I do the plus minus on the right side. If I could simplify 17, I would, but I can't. And all I have to do now is add 8 to both sides, and I get x equals 8 plus or minus the square root of 17. A common mistake that people make at this point is they FOIL that out, then they bring the 17 over. Not exactly a mistake, because you can still get the right answer, but you will have done a lot of extra work, because after you FOIL that and bring the 17 over, then you go back and use the quadratic formula and you'll finally get back to this. This is set up perfectly for that plus minus theorem or the square root theorem. All right, let's take a look at something different. Number 7 is a rational equation, meaning that I have a fraction in my equation, and whenever I have a variable in the denominator, I want to be careful, because what can I not have down here? Well, I can never have 0. So you can ask yourself right from the beginning, what number would x be that would make this denominator be 0? And it's pretty easy to see. If x was 6, then I have 6 minus 6 is 0, and then that would be undefined. So as you're working this problem, you would then say, I can't let 6 be my answer, because 6 then would lead to a problem. But how do you solve this problem? Well, you're going to multiply everything by the least common denominator. And remember, this has a denominator. The common denominator here is just x minus 6. I'm going to write it next to each term so that I don't forget that it's in. I put a 1 under there so I don't forget that it's over 1. And here I can see that x minus 6 cancels. Here x minus 6 cancels again. Here I don't have anything canceling, so I have negative 7 times x minus 6. Okay, so I'm going to distribute this over here, get negative 7x, and then positive 42, because negative 7 times negative 6, right? Always have to distribute all the way through the parentheses. Simplifying on the right side, I get negative 6 and positive 42, which is 36. And then I'm going to add 7x to both sides. I'm moving all the variables to one side. And I'm going to add 12 to both sides, moving the constant terms to the opposite side. And then I get the coefficient to be 1 by dividing by the current coefficient of 8, and you get x equals 6. And if you remember what we said, we can't let x be 6, because 6 minus 6 would be 0. So in this case, even though we didn't make any mistakes, we can't use our answer because it would cause, it's a restriction for the problem. We can't let x be 6. So there is no solution to that problem. And that's something that you always want to check for extraneous solutions when you're working with rational equations, to make sure you didn't get something that can't be used. Okay, let's take a look at this one. It's a little different. We can find the LCD, but it's going to take a little bit of work. And what I'm going to first do is factor this. And if I factor it, I get 9 and x plus 3. So the reason I did that was so that I could then say, what is the least common denominator? Well, this fraction needs 9 and x plus 3. So that's our LCD, because this one needs an x plus 3, which would be represented here. This one needs a 9, which is represented there. So it's as easy as 9 and x plus 3. You always want to factor when you can, in order to find the correct LCD. Again, I'm going to write it down next to each term so I don't forget to multiply it. Every single term gets multiplied, whether it had a denominator or not. So here you can see that 9 and x plus 3, the whole thing goes away. Here my x plus 3's cancel, and I have 9 times 8, which is 72. Here my 9's cancel, and I have negative 2 out front and x plus 3. So now if I want to solve this, I'm going to distribute negative 2x minus 6, and I have 76 minus 6, which is 66. And then I'm going to subtract 66 from both sides. 4 minus 66 is a negative 62. And if I divide both sides by negative 2, I get x equals 31. And that's okay, because the only problem I would have had is if I got x equals negative 3, right? Because negative 3 plus 3 would have been 0, and so that's x equals negative 1 is not a problem. It's not a restriction for our problem, so we're okay with that one. All right, let's go on to the next one, which is simplify. We're subtracting here, but we're not solving. You see how there's an equal sign in that rational equation up there, number 8. So because there's an equal sign, I can actually find out what x is. This does not have an equal sign. It's just a rational expression. All I can do is combine those, simplify that, but I can't actually solve. I don't know what y is. I'm not going to find out what y is. The first thing I'm going to do, though, is factor the two denominators. So I have negative 2, and then I have y plus 4 and y minus 4, because that's a difference of squares. And over here, for the second one, I have y squared, which is y and y, and I have 8, which could be 1 and 8 or 2 and 4, but since I want 6, I'm going to use 2 and 4 again. I'm not teaching you how to factor here, so if that's just like totally foreign, then you want to go back and study that somewhere else. What's the least common denominator? Well, in order to be a least common denominator, it has to represent all the fractions. So the first one has a y plus 4 and a y minus 4. That represents that fraction. Now I move to the next fraction, y minus 2. I don't have one of those yet. And a y minus 4. I already have that. So my least common denominator is y plus 4, y minus 4, y minus 2. So I'm going to multiply both of these fractions by the least common denominator. And I'm going to write it twice, just so I don't cross something out in the first one and forget about it for the second one. Y plus 4 and y minus 4 cancels, and I have a negative 2 times y minus 2. And then, oh, yeah. So what's happening here is you can see that I kind of got on a roll, but I really am saying the wrong thing. I want this to have all 3 parts in it. So I'm putting in the y minus 2, and that means I have to multiply by y minus 2 on the top. I am not canceling the denominator. That would only be if I had an equation. So I'm sorry, but you know, people make mistakes, and I just did. But I can't do this. Let's look at it over here. What I'm really doing is I'm saying this is what I had, and this is the denominator that I want. In other words, I want a y minus 2 in there. If I put one on the bottom, I've got to put one in the top, because I can't just change the denominator. And so when I come over here to the second half, I have a y minus 2 and a y minus 4, and I need a y plus 4. So on the second one, I'm going to put y plus 4 in the top and bottom. I did not cancel out the denominators because I can't do that. And then I'm going to say my whole new fraction is over my least common denominator. So forget this happened. Erase that from your memory. And then up here I have negative 2y plus 4. I'm just going to write the denominator once because you know when you have the same denominator, it goes over that common denominator. And here, this is like a negative 3. So I have negative 3y minus 12. And that means that my final answer, negative 2y and negative 3y, is negative 5y. 4 minus 12 is negative 8. And on the bottom, I have y plus 4, y minus 4, y minus 2. And that's going to be my final answer. Again, I'm not clearing out the denominators here. I'm just putting the denominator together into one common denominator, just like I would if I had 1/2 plus 1/3. I wouldn't clear out the denominator. I would say I'm going to make that a fraction over 6, right? So that's what you have to do when you're working with those. Okay, last one for this video. This video is taking a long time, but the last one is something called a complex fraction. I have fractions inside of fractions. So I'm going to start by factoring each denominator. X squared minus 1 is x plus 1 and x minus 1. And then over here, I'm taking out the 4, and that leaves x minus 1. Then I have 1 over x minus 1 and 4 over x minus 1. And from that, I can see what the least common denominator would be. And the least common denominator would be x plus 1, x minus 1, and a 4, right? There's a 4 outside of there, so those are going to be 3 parts. And what I'm actually doing here is I'm multiplying the top and the bottom by the same thing, because anytime you want to change a fraction, you can change it as long as you do the same thing to the numerator and the denominator. I'm going to multiply by 4 x plus 1, x minus 1, all the way through the top there, and then all the way through the bottom here. All right, so up here, when I multiply that top one, my two binomials are going to cancel, and I'm going to get 4 times 3x, which is 12x. And the second one, the x minus 1 cancels and the 4 cancels, and I get negative 7x plus 1. On the bottom, when I multiply the first one, the x minus 1 cancels, and I get 4 times x minus 1. Oh, that should be a plus. Sorry. And then on the second one, the x minus 1's cancel, and I get 4 times 4, or 16x plus 1. All right, now I'm going to simplify the top. In 12x minus 7x is going to be 5x. Minus 7 times 1 is negative 7. And on the bottom, I have 4x plus 4 and 16x plus 16. So 4x and 16x is 20x, and 4 plus 16 is 20. And that is as far as I can go. If I could, I would simplify this, take out a common factor and simplify it. I can factor this a little bit, like I could say that this is 5x minus 7 and then 20x plus 1, but that doesn't help me cancel anything. So this is a perfectly acceptable place to stop. All right, have a fantastic day, and I'll see you next time.